Hey guys, we're going to do prime factorization today. So prime factorization is just when you find all of the prime factors of a number. So how you're going to do this is we're going to make factor trees to help us. So we're going to choose any two factors of a number. And as you're making your factor tree, you're going to circle all the prime numbers. So that tells you when to stop. And that also helps you go back and find all the prime factors so you don't miss any. Then you're going to just keep repeating those same steps until you have all prime numbers and all the numbers are circled at the bottom. The last step will just be to write out the prime factorization least to greatest. Remember, prime factorization, we're finding factors, so we want to use multiplication when we write out the prime factorization. All right, and this will make more sense when we do a few examples. So the first example I want to show you is the prime factorization of 40. Now I'm actually going to do this 3 different times just to show you that it doesn't matter what order you do it in, you're still going to get the same prime factorization at the end. So my first one, this is going to be student A, student B, and student C. So student A looks at 40 and says, oh, I can break that up into 2 times 20. 2 is a prime, so I'm going to circle it. And then I have to break up 20 because it's not prime. And they might say, oh, I can break that up into 4 times 5. They also could have said 2 times 10. It would have worked the same. 5 is prime, so I'm going to circle it. I can break 4 up into 2 times 2. Now you should notice everything is circled. Like we can't create any more prime factors on any of those numbers. So we write out the prime factorization least to greatest. So I have 3 2's and a 5. Now if you went through and you multiply those together, you should get 40 if you did everything correctly. 2 times 2 is 4, times 2 is 8, times 5 is 40. Okay? All right, then student B looked at it and said, oh, I can do 4 times 10. And neither of those are prime, so they would have said 4 is 2 times 2. Those are both prime. And they would have said 10 is 2 times 5. So what do you notice? The prime factorization is still 2 times 2 times 2 times 5. Same as it was with student A. And then student C says, oh, I can do 5 times 8. 5 is prime, 8 is not, 8 is composite. So 8 can be broken up into 2 times 4, where 2 is prime. 4 can be broken up into 2 times 2. And student C is still going to get 2 times 2 times 2 times 5. Okay, that's why we write it least to greatest, just so that it makes it clear that any way you do it, you're going to get the same prime factorization. Okay, it's still the same if the numbers are in a different order. This just helps make it very clear that they're all the same. They have to be the same, because if they were different, they wouldn't multiply to give you 40. That is the only way you can multiply prime numbers and get 40. You notice we could multiply 2 composite numbers or a prime and a composite, right? You could use different factors that way, but if all of the factors are prime, there's only one way to do it, and that is 2 times 2 times 2 times 5. Okay? All right, a couple more. So 63. So 63, I would notice 63 is a multiple of 9. We can do 9 times 7. 7 is prime. 9 can be broken up into 3 times 3. Both are prime. So we're done. So your prime factorization is 3 times 3 times 7. Okay? Last one. 57. Now this one might be a little bit trickier. You might not recognize anything right off the bat. Using our divisibility rules, though, it's not divisible by 2. It's not divisible by 5. Let's add them together. 5 plus 7 is 12. So that tells you it has to be divisible by 3, because 12 is a multiple of 3. But Off the top of your head, you probably don't know the other factor. So how do you figure that out? You divide. 3 gives in a 5 one time. 3 gives in a 27 9 times. Okay, so that tells you 3 times 19 equals 57. 3 is prime. Is 19 prime? Well, let's think about it. Is it divisible by 2? No. 5? No. 1 plus 9 is 10, so it doesn't work for 3. Is it divisible by 7? No. 11? No. 13? No. 19 is prime. So that prime factorization is just 3 times 19. And sometimes that'll happen. One other thing that I did not put on here. Every now and again, you will get one, oops, I don't have another slide. So you might get one like 13. Get my pen back. So maybe you get one like 13. Okay, or you might get a larger prime number. If they give you a number that's prime, the prime factorization is just that. You can put 1 times 13. I'm not sure if it'll take it or not. But the best way to do it is just to type the number in. Prime factorization of 13 is 13 because it is prime. All right, so good luck and let me know if you need any help.